Hello everyone and welcome back. So we're going to look at this problem from this state, and then we will go back and figure out if we need to do anything to make it work with the sim or the transformation part. Because right now I have both data. I have it here, okay? So I have the deformation, and then I have the carve node, which I animated to go from 0 to frame to 1 at frame 90. So this is the how long I expect the curves to how long the curve expansion is going to take, and then I'm just restoring the position which we stored it as, I think, origin PT or rest. This is just the original state of the points, nothing more. So if we go here, say v at origin position is equal v at p, and then whatever we do, we can restore to that to the original state. And what I decided to do is deform them and then apply the carve and then restore them back. And I can look at this problem this way. I need to figure out the points emission at this state, so I don't have to worry about anything else from above. Let's put down a null, say ignore everything above. Okay, so let's take a look at this. So what's happening is if I play through, we will see that the crack is not giving me the result that I want, but there is one thing different between each of these points or each of these curves. If I put down a time shift, it's really complicated. Hopefully I can explain it. Let's see, it's time shift. Yes, if we put down a time shift of 1 frame, okay, back, and compare both of them, no, 1 frame is not going to work. So let's do this. Let's increase. Let's turn off this and go every 10th. So like this, okay. And if we template this and say $FF minus 0.1, now we're going 1/10 of a frame. Okay, now this is the position, the current position, and this is the previous position of the curves. And I need to flatten everything. So let's make sure we're looking at it here. Okay, so this is my So this is my current frame, okay? And this is my previous frame. I'm gonna add a transform node and shift it so we can see them side by side. That's it. So this is the original one, and this is the 1/10 of a frame behind it. So original is in front, and the other one is behind it. Now, if we think about it, if a point is moving along the curve, there is only one point where the previous frame is not overlapping with a curve. I'm gonna try to draw this. Amazing drawings. Okay, so we have one point, and it's going like this, and it's doing this, and then at the same time this is going like this. There's one point at the tip of each of this. So if we go back all the way, if we go back like this and move this point, there's always a frame where it's overlapping with a curve. Okay, and what we want to do is we want to check 1/10 of a frame back. If that position is still hitting a curve, then we delete it. If it's not, that it means it's a tip. That means it's propagating along the correct path. And what this is going to give me is, let's say, okay, let's say this path here. Okay, I'm gonna draw it. I'm gonna draw that top curve again. So this is the first one, and it has a tip. Okay, this tip is moving, and at this point, there's only, for example, this curve. It didn't move yet, and this one hasn't been born yet. So it only has a point here. And if we keep projecting it back onto the nearest curve, it's going to intersect, always intersect, always intersect, until it starts moving. If it moves and we check on the previous frames, then it's different position. It's not intersecting with a curve. So we need to basically move everything and then compare it with the previous frame. If it's still intersecting with a curve, then we delete it. If it's not, that means it's propagating along a unique path for the first time. It's complicated, trust me. It took me days to figure this out. So basically, I'm gonna show it here. I go over each curve. So this is all my curves, and I'm gonna work on just a few of them to make it faster to work with. Delete. Okay, so let's say we have these curves, okay, and I'm gonna loop over each one of them. And keep everything except delete everything except the tip. So right now the curves are inverted. I can use the maximum number of points and delete the one that has the highest point count, or that is equal to the number of points minus 1 with that ID, or we can simply reverse the order of the curve and then delete the first point. So we have that, and if we play through, it's gonna keep going. Okay, it's gonna keep moving along because of the carve animation. And in some cases I was losing attributes from this, so what I did is I kept everything here, and then I simply copied the prim class and name, and the prim class is the ID, the primitive ID that we're going to intersect with. So each curve has an ID. And then if we loop over each one of these, you will see there is one point at the tip always moving. But some of them, let's template, I'm going to template all the curves. Some of them are overlapping. So like this 19 is overlapping with a curve. I'm going to delete it. This number 2 is overlapping with a curve. I'm going to delete it. This one is not, because it's not going to intersect with anything, but this one is on top. Now, how do we get to keep these points safe? We can either go back 1/10 of a frame, or we could add a tiny carve on the source. So if I do this, well, it's not a tiny carve, but it's a big carve. It's 0.999. We can go stronger if we want, but it didn't matter. So this is the curve I'm going to compare against. It's the result. I carved it, so I removed the tip of all these curves. And then if we look at the points and template this, you will always see a gap between the tip. I think I should have explained it like this. So if we look at these points, this doesn't have anything to intersect with. Look, if we project it down, it's not going to hit any primitives. This one is I deleted. This one is, this one is, this one is. So unless there is no curve underneath it, I'm going to keep it. If we do this, and this is what I've done, I've moved the points just a tiny bit and then shoot them down. And then if they intersect, I delete them. If they don't intersect, I keep them. Or basically, I colorize them with red and black in this case. So the red ones are intersecting, not intersecting, the black ones are. If we do this on a solver now, I'm going to lower the number of substeps because it's happening too fast. I needed to use 10 substeps. If we cache this, let's see. Yeah. Okay, so we have only 2 curves. That's fine. So if we cache this and look at it, we will see 2 red points, and then everything else we don't care about. Once the crack is going to split, we will see another red point splitting exactly what it needs to. See? This one, for example, it split at a reasonable moment. It's not exactly the same, but there's only one point where that happened. Okay? And if we use this as the source of our animation, we will get this. So this is the particle sim, and we will see the propagation is much nicer. That's it. That's how I solved it. And I didn't cache it to disk because I needed 10 sub-steps, so I just let this happen live. And let me delete, let's do this. I'm gonna delete everything that is not red. And let's trail it. So let's trail. And let's put down 10. The increment is 0.1. Let's put down 20, maybe 40. And then if we use an add, and let's see, should have an ID or something. Yeah, let's try. By attributes. Let's try prim ID. Nope. PTID. Nope. So I don't have anything at the moment that I can link this with, but with the animation we can do that. I think I could have implemented this as well. Yeah, I don't have any attribute here. But this is the result, and if we look here, we will see that we have a nice growing path moving along. And it's splitting. It's not 100% correct, but it's much better. And one of the other biggest issue is that this carve is giving me a point per primitive. So we're getting multiple points on top of it, all this. So the carve is never going to be correct. See, we have 10 or 15 just overlapping on top of each other. And this technique is going to solve that. And then all we have to do is basically prep it for sim, or use it in the sim really. So this is my points. And because we have that original position, remember when we did the transform here, we still have that position. It's stored as anim pose. It's still propagating through, and if we simply restore that after the calculation of the points, we will be able to restore the points where they need to be, and then we use them to emit particles. And I'm gonna show it here. So this starts at frame 75. I'm gonna lower the sub steps. And let's set this to 1. And it's starting to emit and propagating through. So that's pretty much it. The trick really is to get the nice propagating point traveling through without any other duplicates behind it. And maybe you guys can come up with a better solution or something simpler than this, but to me, carving out the previous primitive and making sure that that point doesn't have anything behind it worked really, really well. And because it's happening super fast, actually no, sorry. So the reason we saw that snapping that we had is because I didn't use enough sub-steps. So if we use 10 sub-steps, it will have enough time for that point to check and make sure that it's expanding correctly, and the motion is going to be much better basically. And 10 sub-steps is required because this whole thing happens in 13 frames, and it's not enough to just use one sub-step. So I use 10 to make sure that I capture everything. And also for the sim, because it's happening too fast, I use 10 sub-steps in the final version. And I'm gonna do a play blast of this so we can see it all together. Thank you guys for watching, and see you in the next video. Bye bye.